Hello, everyone. This is John Grace, a doctorate student at California Intercontinental University. And today I will be presenting my Unit 4 presentation for conducting a correlational analysis. Let's get started. So for our agenda for this PowerPoint, first we'll talk on our introduction, then we'll move on into stating and justifying the null and alternative hypothesis and the rejection rule. Provide supporting details and findings in APA format, conducting correlational testing using PSPP, analyze the output from PSPP and relevant hypothesis test results for the 6 significant correlations, discuss main takeaways from the presentation, and finally we'll end the presentation with a quick Q&A. So progressing on into our introduction, we were tasked with conducting a two-tail hypothesis test and correlational analysis on a given data set. We will demonstrate the ability to conduct a correlational analysis, and we'll be presenting our findings from the analysis of the correlational test. We will utilize PSPP software to import and analyze the data set gathered into PSPP and calculate the following correlations to find significance and follow up in APA write-ups. 1. Income and debt. 2. Income and savings. 3. Income and stocks. 4. Income and wallet. 5. Debt and savings. 6. Debt and stocks. 7. Debt and wallet. 8. Savings and stocks. 9. Savings and wallet. And 10. Stocks and wallet. We will discuss 6 significant correlations that emerged through this research. Let's continue. So moving into our continued introduction, let's note that the correlation coefficient and its p-value were calculated using PSPP, assuming alpha was equal to 0.05. The data set was generated using a SurveyMonkey survey asking participants located in the Midwest United States, which just happens to be where I am from, questions regarding their income, debt, savings, and other important personal finance factors. The data set is a distillation of the full survey data and contains the following variables. Income. This is the self-reported income of the participant in US dollars. Debt. This is the self-reported debt of the participant in US dollars. Savings. This is the self-reported savings of the participant in US dollars. Stocks. This is the self-reported portfolio valuation. This includes stocks, bonds, and 401k of the participant in US dollars. Wallet. This is the self-reported amount of cash the individual carries in their wallet or purse. NUM-CARs. The number of car payments per month by the participant. NUM-C cards, the number of credit cards maintained by the participant. NUM-defaults, the number of defaults, all types, incurred by the participant. And LIC comfort, the self-reported comfort level of the participant with the current financial standing. The measure used a Likert scale where 0 was very uncomfortable to 4, which was very comfortable. Let's move on to the next slide. So jumping into our hypothesis test number 2 of 10, income and savings, a significant result was found. So for our second hypothesis test, the following correlational test was conducted, where null hypothesis was that there is no correlation between income and savings, as to where our alternative hypothesis was that there is a correlation between income and savings. The correlation coefficient and its p-value were calculated using PSPP. Assuming alpha was equal to 0.05, a significant correlation emerged between the correlation coefficient, which was equal to 0.908, and the p-value, which was basically equal to 0. The test rejected the null hypothesis and concluded there was a correlation between income and savings. Moving on to our next slide, hypothesis test number 3 of 10, income in stocks. Once again, a significant result was found. Third hypothesis test, the following correlational test was conducted. there is no correlation between income and stocks was our null hypothesis. And for our alternative hypothesis, there is a correlation between income and stocks. The correlation coefficient and its p-value were calculated using PSPP, assuming alpha was equal to 0.05. A significant correlation emerged between the correlation coefficient, which is equal to 0.194, and the p-value, which was equal to 0.018. The test rejected the null hypothesis and concluded there was a correlation between income and stocks. So moving right along, hypothesis test number 4 of 10, income and wallet, a significant result found. Our fourth hypothesis test basically stated that the following correlational test was conducted. There is no correlation between income and wallet was our null hypothesis. And for our alternative hypothesis, there is a correlation between income and wallet. The correlation coefficient and its p-value were calculated using PSPP. Assuming alpha was equal to 0.05, a significant correlation emerged between the correlation coefficient, which was equal to 1.000, and the p-value, which is equal to 0. The test rejected the null hypothesis and concluded there was a correlation between income and wallet. Now, chugging right on along to hypothesis test number 8 of 10. Savings and stocks, a significant result found. 8 hypothesis tests. The following correlational test was conducted. So for our null hypothesis, there is no correlation between savings and stocks. And for our alternative hypothesis, there was a correlation between savings and stocks. The correlation coefficient and its p-value were calculated once again using PSPP, assuming alpha was equal to 0.05. A significant correlation emerged between the correlation coefficient, which is equal to 0.284, and the p-value, which was equal to 0. The test rejected the null hypothesis and concluded there was a correlation between savings and stocks. Moving right along to hypothesis test number 9 of 10. Savings and wallet, a significant result was once again found. For our 9th hypothesis test, the following correlational test was conducted. There is no correlation between savings and wallet, was our null hypothesis. An alternative hypothesis was that there is a correlation between savings and wallet. The correlation coefficient and its p-value were calculated using PSPP. Assuming alpha was equal to 0.05, a significant correlation emerged between the correlation coefficient, which was equal to 0.908, and the p-value, which was equal to 0. The test rejected the null hypothesis and concluded there was a correlation between savings and wallet. And hypothesis test 10 of 10. Stocks and wallet, a significant result was found. The 10th hypothesis test. The following correlational test was conducted. For our null hypothesis, there is no correlation between stocks and wallet. And for our alternative hypothesis, there is a correlation between stocks and wallet. The correlation coefficient and its p-value were calculated using, you guessed it, PSPP. Assuming alpha was equal to 0.05, significant correlation emerged between the correlation coefficient, which is equal to 0.194, and the p-value, which is equal to 0.017. The test rejected the null hypothesis and concluded there was a correlation between stocks and wallet. So, moving right along to takeaways. PSPP is a handy tool that can perform fast correlational tests. We can perform tests using the following steps within the PSPP software. Click on Analyze, then click on Correlate, then select Bivariate. Flagging significant correlations makes it easier to analyze the data. You can utilize scatter plot graphs to create a more visual representation of the data. We should always utilize the APA write-ups to easily convey our results. And correlation analysis is not as difficult as it may seem at first. So, we've come to the very end of our YouTube PowerPoint presentation for our GRC class. And this concludes our presentation today. I'm available for any questions or further discussions. Thank you so much for tuning in and have a wonderful day.